And we're going to keep talking about functions. And first of all, let's remember how we identify if something is a function. Remember, for a function, each input only has one output, or each number in the domain only goes to one number in the range. So this one is a function. Each number in the domain goes to only one number in the range. And looking at this table, you can see that this one is a function as well, because each input only has one output. That is the definition of a function, like we talked about in the previous lesson. So what we're going to be doing today is we're going to find some function values. So equations are functions sometimes written like this, okay? And we call this function notation. And what I want you to see is that basically the only thing that changes between equation and function notation is that your y is now going to be written as an f of x. The other side of the equation stays exactly the same. So you can sometimes remember this, y equals f of x. Basically, we're just going to replace the y in our equation with an f of x. That's what function notation does. And what we're going to do is we're going to find values for these functions. So for example, I've got f of x equals negative 4x plus 7. This right here is my function. They will always define the function for you. And then what you're going to do is you're going to find the values of different x values. So I'm going to try to find f of 2. And we read this f of 2. Don't say f2. It's f of 2. And the way we find f of 2 is, notice, the way I went from f of x to f of 2 is that I replaced my x with a 2. So on the left side of the equal sign, if I draw a line down, we replace the x with a 2. So what I'm going to do is I'm going to do f of, and I'm finding f of x. That's the part I plugged in on the left side, or sorry, I'm finding f of 2. I'm finding f of 2. I plugged in a 2 for x on the left side of the function, which means I'm going to plug a 2 in for x on the right side of the function as well. Notice, to go from f of x equals negative 4x plus 7, f of 2 equals negative 4 times 2 plus 7. I simply replaced both of the x's with the 2. They told me to find f of 2, so my x's become 2's. And then I just simply evaluate this. Negative 4 times 2 is negative 8 plus 7. And then f of 2 equals negative 8 plus 7, which is negative 1. So f of 2 would be negative 1. Now this one looks a little bit more complicated. I'm finding f of negative 3, and then I'm adding 1 to it. So whenever you see a problem like this, where it's more than one thing going on, the first thing I want you to do is go ahead and find out what f of negative 3 is. So f of negative 3, notice I replaced the x with a negative 3. F of x is now f of negative 3. So my x's are all going to change to this negative 3. I have negative 4 times, instead of x, I'm going to write negative 3 plus 7. And then I just simply evaluate this. And this is not f times negative 3. This is just one piece. This is like a label. F of negative 3 is just a label. I don't want you to rewrite that as negative 3f. That is wrong. Do not do that. It's just f of negative 3. This is function notation. You don't have to try to rewrite that or anything. And now I just evaluate the right side. Negative 4 times negative 3 is 12. 12 plus 7 equals 19. Now that I know f of negative 3 is 19, I can just substitute in using my substitution property. I can write 19 instead of f of negative 3 plus 1, and 19 plus 1 gives me 20. Do these problems this way. It may seem like a lot of extra work, but it keeps you from making a mistake. So make sure to try to do them this way to eliminate any mistakes.